Hi everyone, this is Dr. Vaughn. I am going to record a video to show you how to do multiple regression. So I'm using a data set that was obtained from Cengage, Houghton Mifflin at the following website. So here's the link to the website. I've already loaded up SPSS and I've copied the data that we're going to look at into the various columns. I've also populated under the variable view the name and made sure that the measure was set appropriately. So the first variable here is the systolic blood pressure. We have the age, which is in units of years, and then the weight, which is in units of pounds. So we're going to see if the dependent variable of systolic blood pressure is dependent upon or can be correlated with the two variables, both age and weight. So we're treating age and weight as the independent variable and systolic blood pressure as the single dependent variable. So the first thing that I want to do is to look at the correlation values, because if these aren't correlated with each other individually to a sufficient enough level, which is a rather subjective term, then we wouldn't even bother doing linear regression, or we wouldn't have any confidence in the linear regression model that we actually built. So we're going to go to the Analyze menu and go to the correlation and do a bivariate correlation in SPSS. Now, here's the thing. In SPSS, you can actually do correlations between all three of these variables at the same time. So I'm going to move all three of these over. And what this will do is it'll compute for me a correlation table where it'll show me all the values between each of these three variables. There should be 9 total correlation values, but each variable correlated with itself will be 1, and then each variable correlated with each other should be the same regardless of which order you did it in. So there's really only 3 numbers in this table that we're going to be interested in: the correlation between systolic blood pressure and age, the correlation between systolic blood pressure and weight, and then the correlation between age and weight. So you can look at the options, you can set some of these other things, but we're really only interested in this Pearson correlation coefficient. So I have everything set, and I'm just going to press OK. Now, in the output window, you get this correlation table over here. And what it's showing you is each of the 3 variables and then each of the 3 variables over here. We don't really need to worry for now about the significance level or the n. We're just looking at the Pearson correlation. So this is the one where you've correlated a variable with itself. Systolic blood pressure with itself has a correlation of 1, a perfect correlation. We would expect that. Systolic blood pressure with age is a 0.979. That's a very high correlation. So the higher someone's age is, the higher their systolic blood pressure, and vice versa. And similarly, weight. The higher someone's weight is, the higher their systolic blood pressure is. This is based upon the data that we have. And then here's the third one: age and weight are correlated at 0.946. So all 3 of these are very, very high. You don't need them this high to do multiple regression. So when you're making up data for your example, don't worry if they turn out to be 0.4 or 0.5. That's good enough to do multiple regression. These are very, very high. But that is what it is. So you might want to actually extract this table, like copy it and then paste it into your Word document. So copy and then go to your Word document and paste. And then this is how you can report your correlation values, which is part of the project that you've been asked to do. All right, so now I'm going to close this particular output window, and we're going to go back to our data set, and now we're actually going to build the multiple regression model. So we're looking at this as being the output, the dependent variable as being the y, and then we're going to have an x1 and an x2, age and weight. So I'm going to go up to Analyze, and I'm going to go to Regression, and I'm going to build a linear model. Now I'm going to set the dependent variable to be systolic blood pressure, and I'm going to put age and weight over here into the independent variables. You can click and drag, or you can hit the little arrow button. So I have 2 independent variables, 1 dependent variable. You could look at some of these other kind of options that you have available. But honestly, I think that for just a simple multiple regression model, I don't think I need to change any of these options. Let's go ahead and give it a shot. I'll press OK. So what this does, it gives me a whole bunch of different kinds of things. It's giving me the R² value, the R value of the model itself. But what I'm really looking for in this, I'm going to go all the way down to this coefficients table. And I'm looking at these numbers right here, the unstandardized coefficients that are in the B column. So here's the constant term. This is the coefficient of the age variable, and this is the coefficient of the weight variable. All right, so I go over into my Word document and I'm going to make the model. So the first thing I'm going to do is let Y be the systolic blood pressure. Okay, I'm going to let X1 be age, and I'm going to let X2 stand for weight, using X's again for independent variables and Y for the systolic blood pressure. Okay, our multiple regression model then from SPSS is, so we use a Y hat for being the predicted systolic blood pressure as opposed to an observed systolic blood pressure. We're making a prediction about systolic blood pressure based upon inputs which are given for age and weight. So I'm going to choose this little hat function and put Y hat is equal to, and then you're going to go to your SPSS, going to take the constant term, which is out here by itself. Some people put this out front, some people put it at the end. I'm going to put it out front, 30.994, and then plus, now I'm going to do the X1 term, so 0.861 goes with age is X1, so I'm going to go 0.861 times X1, which is age, plus, and then I'll go over here to my coefficient of the weight, which is 0.335. So 0.335 times X2. All right, so this is my model. This is my multiple regression model. Again, we had high correlation, so we have pretty good confidence that this is going to make good predictions as long as we're within the range of the observed values for X1 and X2. So if you go all the way back to our data set, back in SPSS, the age ranges from 52 to 74. The weight goes from, 167 up to 220 or so. So as long as I pick an age that's kind of within this range and a weight that's within this range, I'm going to be able to make a pretty decent prediction about the systolic blood pressure. So in order to use this model, if I wanted to say, okay, what would the predicted systolic blood pressure be for someone who was 60 years old and weighed 195 pounds? I'd plug 60 in for X1, I'd plug 195 in for X2, and I'd do this calculation, and out would pop my predicted value of the systolic blood pressure. All right, so I want to keep this video short. I think that I've given you a short overview of how to use some of the tools that are available in SPSS. Remember that you're supposed to make up your own variables. You're supposed to collect, gather, or find your own data that goes with this. And I wish you all the best of luck. Please let me know if you have any questions as you're trying to complete your project for this week. Have a good day.